Hey guys, Mr. Backer here. In this video, we're going to look at loans and mortgages. So an annuity is a sequence of equal period payments, and when you take out a loan or when you take out a mortgage, that's an example of a type of annuity, because the bank is assuming when they give you this loan or when you take out a mortgage that you're going to make those periodic and equal payments, and typically you're making those payments monthly with a loan. So what banks typically do when they calculate your monthly payment is they look at the present value of your annuity. And there's a formula for finding present value. So in this formula, to find the present value, we take R, and R is that periodic payment that you're making. I is the interest rate per compounding period. And we find that by taking our interest rate divided by the number of compoundings per year. And the N value is the total number of payments that you're going to make over the life of this annuity. And we calculate this by taking the number of compoundings times the time frame, or the number of years. So let's say we're looking at buying a car, and the car is going to cost us $18,500. Now we have $2,000 to put down as a down payment, meaning that we're going to have to borrow a little bit of money from the bank. And let's say the bank gives us a 4-year loan with an interest rate of 2.9%. And what we want to do is figure out what our monthly payment is going to be. Now, as we're looking at what's happening, the car cost $18,500, but we've got $2,000 to put down as a down payment. So we're really going to have to borrow $16,500. Now we're going to think about that present value formula. And since we're trying to find the monthly payment, we're actually solving this to figure out what our R value is. So the present value of our annuity is the amount that we're borrowing. That's the amount of the loan. So that's the $16,500. I'm going to plug that in for the present value on the left-hand side. We don't know our R value. That's what we're trying to find. But in this fraction here, we've got 1 minus 1 plus the I value. And the I value is the interest rate divided by the number of compoundings, or the number of payments that you're making. Now, we said that we're going to be making monthly payments, so we're going to be taking the 0.029 divided by a K value of 12. And then I'm going to have to take that and raise that to the negative N power. N is the total number of payments that we're making. This is a 4-year loan, and we're making monthly payments, so we're going to make a total of 48 payments. So our N value is 48. So I need to raise this to the power of negative 48, and this is all over that I value, which again is the 0.029 divided by 12. So now what I'm going to do is I'm going to take this entire fraction right here, and I'm going to type that into my calculator. When I type all of that stuff in, I get about 45.27. Now, if I'm trying to solve for R, then I'm going to take that 45.27 and I'm going to divide that over to the other side. And when I do that, I should get an R value of 364.48. So since the R value is that payment amount, then we're going to have a monthly payment amount of $364.48 to pay off this $16,500 loan over this 4-year period. That's going to be it for this video. Thanks for watching.